Okay, so now let's go to question number. Okay, so what we have, let's see. Question number 5, question number 3, 3A and B and C and A and B and C has to be totally memorized. That means question number 3, it's just a matter of total memorization, so get it by heart. Okay, so question number 3 has to be memorized. Okay, now we are going to question number 4. Give the question number for 4A first states that give the systematic name of acetone. The systematic name of acetone. Okay, so before going into the systematic name, we must first know that what's the rule for naming. I have already discussed that several times in the class. Still, I'm going to discuss it again over here. Okay, so I think you remember the meme that Kana Chocos alcohol amne kinna halaise, isn't it? You do remember? If not, okay, that's not a problem. I'm repeating it. So it would be Ka na. Ka stands for carboxylic acids, Na stands for nitrile. Kana chocos alcohol amne means amine. Amne kinna means alkene. Halaise means halogen. Okay, so between kin and hal there is also alkane. Okay, so this is the priority sequence for naming of organic compounds. Okay, so what was the compound actually? The compound was acetone. So these are the skeletal formula given. So acetone. Okay, acetone. OH. Acetone. Okay, so this is the skeletal formula given. Let's draw the displayed formula first. So here is one carbon, carbon. This is labeled as OH, so this is not a carbon, this is a carbon. So 1 2 3 4 4 carbons. 1 2 3 4 4 carbons. So 1 2, there is a double bond O. Third carbon, there is an OH, and let's fill the other bonds with hydrogen. Okay, so this is the formula. Look, this is the ketone, this is the ketone, and this is the alcohol group. The ketone having the most priority, so the name should end with the most priority group. Just remember that name has got 3 parts. The part at the left is the most priority functional group. The part in the middle is the chain name. The part in the middle is the chain name, which may be in for alkene or which may be N for alkane. And okay, in or N. And here it contains the less priority functional groups. We must try to give we first have to pick up the longest chain, which is this one. In this case, the longest chain is this one, so this one in this case, and then we put numbers on the carbon in the longest chain so that the most priority group gets the least number. So it's 1, 2, 3, 4. Okay. Okay, so the more priority group is ketone, so it should end with O N E, and we must mention the position. It's the second carbon, so 2 on, 2 on. Okay, the main chain has got all carbon carbon single bonds, so it's butane. Since there are 4 carbons, so but and all single bonds, so N. Butane 2 on, and in the third carbon we have got a hydroxide, so 3 hydroxy. Just remember, when hydroxide is a lower priority group, we should write it as hydroxy. But when hydroxide is a higher priority group, for example, alkene is present or halogen is present and hydroxide is present, in these cases hydroxide is more has got more priority. If hydroxide is the most priority group, then the name should end with all, but here in this case hydroxide is not the most priority group, so we are using hydroxy. So this is the name. Okay, what about the next question? The next question says, identify the reagents and conditions for the conversion of acetone into diacetyl. Okay, let's see what is the change. So the change is, I will be drawing the structural formula of both cases. So it's CH3CO CHOH CH3. So what happens is that it's CH3CO, then here is another CO and CH3. So what happens is that 2 hydrogen has been removed from here. That means it is oxidation. Or suppose you don't know that what's going on here, it's difficult for you to predict. Suppose, so look, here this part is unchanged, this part is unchanged, this part is unchanged, but here from here 2 hydrogen has been removed, and removal of hydrogen, what you know, is known as oxidation. So this reaction must be oxidation. And in another way, this is alcohol, this is ketone. So alcohol, the secondary alcohol is oxidized to ketone. Why this is a secondary alcohol? Because if this carbon you consider as the alpha carbon, and there are 2 carbon atoms attached to it directly, which we call the beta carbon. The direct attached carbons are the beta carbons. So there are 2 beta carbons, so this carbon must be 2, that means secondary. So that means this is a secondary alcohol, and secondary alcohols are oxidized to ketones. So the condition is, we will be using any oxidizing agent like potassium dichromate or potassium manganate, acidified, then heat, warm, etc., etc. Reflux is not necessary in this case, but you can write, because ketones are not that much volatile as the aldehydes. Okay, so what was the next question? The next okay, infrared. Explain the main features of this spectrum with reference to the wave numbers greater than 1500. Okay, so greater than 1500, isn't it? Okay, greater than 1500. Look, we have a peak at 1600, 1700, just greater than 1700, which may be 1720 or 30, etc. So there is an absorption peak at 1720, we can say. So this must be due to CO double bond, isn't it? CO double bond. Just look at the data booklet. I'm not going to depth. You just go to the infrared data booklet page and look that if there is an absorption peak between 1670 to 1740, then it must be due to carbon oxygen double bond. Okay, so we have another absorption peak at 28 which fellow, at 3000, at exactly on 3000. which is due to CH bond. It's a sharp peak, it's strong absorption, so it's due to CH bond. And we have another absorption peak at about 3500, isn't it? 3500 or 3400. So this is due to OH bond for sure. Just look at the data booklet. So the compound must contain carbon oxygen double bond, a carbon hydrogen bond, and oxygen hydrogen bond. Okay. State and explain how infrared spectrum of diacetyl would differ. Okay, so look, diacetyl has got no OH groups, isn't it? So the peak at 3200 and 3650 would not be present. The peak would disappear. Okay, all right. Okay, if a sample of acetone is reacted with concentrated sulfuric acid, a single product is formed that does not exhibit stereoisomer. Acetone reacts with concentrated sulfuric acid. Okay, so concentrated sulfuric acid acts as an oxidizing agent when it reacts with hydrogen halides like hydrogen bromide, hydrogen iodide, etc. And basically it is a dehydrating agent when it reacts with alcohols. Okay, let's go. So this is the acetone. Okay, so look, so this carbon has an OH group, and for dehydration or elimination reaction, the any one of the beta carbon, or maybe in both, the beta carbon must contain a hydrogen. So alpha carbon has got O, beta carbon has got H. So take one O from here, take OH from here and take one hydrogen from here, and it turns out to be CH3CO, C, CH2, one H remains here. Okay, so water is eliminated. So the product is CH3CO, CH double bond, CH2. Okay, and if you want to know its name, so 4 carbon atoms are here, and we have carbon oxygen double bond and carbon carbon double bond. So this is the more priority, so we will start numbering from here, 3 4. So this is the most priority, so it should end with on at position 2. Then the chain has got a double bond, so N, and the double bond is between 3 and 4, so we take 3N, number of carbon atoms 4, so but 3N2 on. Okay, that's the name. Okay, and the question says that this compound does not exhibit stereoisomerism. Okay, first you need to know the meaning of stereoisomerism. Stereoisomerism usually means that structure remains the same, but the position of atoms on the same the position of the attached atoms with the same carbon atom may vary up and down or sideways. Like, let me tell you, I'm again telling it that structure remains the same, but the position of the atoms attached with the same carbon atom just shifts up and down or sideways. Like, look, this is H, this is Cl, this is H, this is Cl. So the structural formula is CHCl double bond CHCl. Now if I draw this ClH, HCl, this is also CHCl double bond CHCl. So they have the same structural formula, isn't it? But with this carbon atom, look, with this single carbon atom, hydrogen is above, chlorine is below, and in this carbon atom, chlorine is above and hydrogen is below. So the structure remains the same, but the atoms attached with the same carbon atom has their position varied. Okay, so these kind of isomers we call it geometric isomers, and in case of the presence of double bond we call it cis trans, and in presence of single bond we call it optical. So uh, same, so a carbon atom must have different groups attached to it. But look at and in another case, if it's a single bond, then there must be 4 different groups attached with this attached with the carbon atom, and we call the carbon atom as chiral carbon. Okay, so here in this case, we don't have any chiral carbon atoms because this 4 single bonds, it is a double bond present, here's a double bond present, and here CH3, so all same groups, all H, so no different groups are so 4 different groups are not present here, so no chiral carbon atoms, so there is no optical isomerism. And with this, and in terms of geometric isomerism, this carbon atom has got 2 hydrogen atoms, that's 2 same atoms attached to it, so there is also no geometric or cis trans isomer. Okay, this is the cis, this is the trans because Cl opposite to the trans. Okay, so this compound has got no chiral centers, or same groups are attached with the carbon atoms in double bond, with a single carbon atom in double bond, so there is also no cis trans isomer, so this compound has got no stereoisomers. Okay, now what was the next question? Explain why the product of reaction of acetone with HBr does exhibit cis trans isomer. Okay, so acetone with reacting with HBr. The product of reaction of acetone with HBr. Okay, so what was acetone? I forgot the structure. Okay, so acetone reacting with HBr. Okay, it does exhibit cis trans isomerism. Okay, so HBr is present here. Let's go to solving. Okay, so acetone CH3CO CHOH CH3 plus HBr. Look, the hydrogen halides or the phosphorus halides, they are very good halogen agents, or they are very good substitutors of hydroxide group. The hydrogen halides or the phosphorus halides like PCl3, PBr3, or PCl5, or PBr5, anything, these groups, they are all very good substitutors of hydroxide ions. So here HBr, this will substitute the hydroxide and put bromine over here. So CH3CO CHBr CH3. Okay, so look, this carbon has 3 hydrogen atoms attached to it, all same groups. There is no carbon-carbon double bond, so no cis trans. Okay, look at here. First let me check 2 different groups. So hydrogen and bromine, they are the 2 different groups. Now we draw a line, and now we check the symmetry on the 2 sides. These 2 sides are not the same, so this must be a chiral carbon atom. So there is a chiral carbon atom or an asymmetric carbon atom is present, to which 1, 2, 3, and 4. 4 different groups are attached. So this compound has got this compound has got optical isomers. And while drawing optical isomers, just remember that we follow the rule of the naming priority. So let's see what we have attached. What are the things we have got attached with this carbon atom? So this is bromine, this is CH3. Hydrogen always has got the least priority. Then we have an alkyl group, we have a halogen. So halogen has priority 3, this has priority 2, and this has priority 1. Okay, so what the rule we should follow is that the most priority group comes at the front, so it has to be CO, CH3, then this is 1, so this is the second priority group, this is CH3, this is the third priority group, this is Br, this is the fourth priority group, this is hydrogen. So 1, 2, 3, 4, or you can also change the position of 2 and 4, there is no problem, but it must be a sequential manner, either clockwise or anti-clockwise. If you are drawing one isomer in anti-clockwise manner, then the other isomer must be in the clockwise manner in the same style. Okay, or if you draw this one as clockwise, then the isomer must be anti-clockwise. Okay, so that's the solving of May June 16 variant 23. Thank you. Okay, tomorrow I will give the solving of May June 16 variant 22. No, I will give it within today, and from now on I will be giving 2 variants everyday solve. Okay, thank you. If you have any problem, please mention it in the comment section, in the Facebook comment. I will try to solve it. Thank you. কতবার থ্যাঙ্কস কইতাম রে ভাই।